Okay, so this week you have to do a lab and you're going to be turning this in. Okay, so I haven't been collecting the homework assignments, but the lab assignments I will collect because I want to make sure you guys do these things. And the first part you're going to have to do is you're going to have to download and install R. Okay, and I tried to just give you a little some hints there, but well, not hints, but just it's rather simple. Just go to Google and type in R. Okay, there's two parts, and you have to download R. So if you type in R, you get the R project, and this is what that page looks like. Go to downloads, okay, and that takes you to CRAN. You just go to you click that. CRAN is like a network of things, and then you pick any of these servers, but probably one in the United States will be best. We actually have a server at UCLA, and so you can pick that, cran.stat.ucla.edu, and download for Mac or Windows or Linux or whatever it is you're using. Okay. If you have like a Chromebook or something where you can't install these things, let me know. We'll try to get you set up with something. That should be straightforward. Okay. And then the other part, so if you download and install R, that's fine, okay? An optional thing, but I recommend it, it should make your life easier, is getting R Studio, okay? So if you search for R Studio, that will take you here, and it looks like this. And basically it's an interface that sits on top of R, okay? So you download R, and that's like the computational engine that does all the calculations, and you can work with it directly if you want to, okay? It's kind of like typing into a command prompt and things like that, and it works, and it's great. But R Studio sits on top of it, and it just kind of adds some features that makes it a little bit easier to work with, okay? And so you just click, get the they changed the site up, but you're just going to click this thing that says Powerful IDE for R, okay? And you want the desktop version, and you want the free one, okay? Because you can pay $1,000 a year for the commercial license, but don't. Just get the free one, okay? And it's really great. What's that?
I said, what if I need 8-hour response?
Yeah. If you've got $1,000 to spare, there's no law against that. Okay. So anyway, you download this, you install it, and it should go. I guess if you have an old computer, the power requirements for R Studio are a little bit higher than R itself. So if you have an old computer, it might work okay for R, but then when you try R Studio, it might not work well. And old being like over 5 years old, okay? And then most of your computers should be okay, okay? But if you have something more than 5 or 6 years old, you might run into problems, and you might have to just deal with vanilla R, okay? But R Studio should be fine. The system requirements aren't super steep, but anyway, you download and install it, and it will look kind of like this. I have a special version or account that I can run it in my web browser. Yours will look more like this desktop version, but I've customized it so it won't look. It will look like this, but not exactly, okay? And so when you download and install R, it'll look probably like this. You start it up, and it looks like this. And you just can start typing away. So let me actually just pull the computer a little bit closer to myself. And you can say, okay, starts off with a calculator, and this is your command prompt. This little symbol right here means it's ready for input, okay? When it goes away, it means it's busy thinking, and don't type stuff, okay? Or, I mean, you can, and then it'll just say wait. Okay, so you can just say, oh, what is 9 plus 5? And you hit enter, and it says the answer to that is 14. You see this bracket 1, okay? The bracket 1 is indicates that the first part of your answer is 14, because R is designed for statistics, meaning generally you are dealing with many numbers at once. And so, for example, there's a few shorthand things, but you can deal with multiple numbers. So, oops. Do I have caps lock on? Okay. So, you know, maybe I have 3, 6, and 9 here, okay? And that just puts 3, 6, 9, and it still says the first part of your answer is 3, and it doesn't label the next one, but the second part and the third part are 6 and 9, okay? If you've typed in a command and you want to repeat it, you can just hit the up arrow, and it will show you what you typed in last, okay? So if you've ever worked with a terminal or command prompt, some things will be familiar, okay? So you can just hit the up arrow to go back through your entry history, and I can do 3, 6, 9, and I'm going to say, well, add 5, okay? And what this is going to do is it's going to add 5 to each of those elements. So you get 3 plus 5 is 8, 6 plus 5 is 11, 9 plus 5 is 14, okay? And then there's a shorthand, so I can do like 1:10, and that's shorthand for saying 1 through 10. And so you can see kind of, I'm going to just do a demonstration. I'll do 50 through 150, and it spits out a whole bunch of numbers, and we see that the first number, bracket 1, is 50, and then the 18th number in this sequence is 67, the 52nd number in this sequence is 101, the 86th number is 135, etc., etc., etc. Okay, you guys kind of see why there's brackets and stuff? And R has this thing, bracket notation, okay? So you can refer to elements in what they call a vector. So the sequence of 50 through 150, there's 101 numbers here. I can reference this, 50 through 150, and I can say, give me back just the first number in this sequence. So if I hit enter here, what will it spit out? 50, okay? And I can use the bracket and say, give me the 69th element in this sequence, and what will it return? 118, okay? Does that make sense? And really what's going on underneath there is it's calculating the entire sequence 50 through 150 first, and then using the bracket notation, it's just returning the 69th element in this entire sequence of 50 through 150. Okay. Anyway, there's some built-in little calculator things for the binomial and normal distribution. Okay. So for the normal distribution, there's essentially a built-in standard normal table, and we access that through the command pnorm. Okay? Pnorm, basically you put in a number here, and it's like looking up the number in the z table. So if I put pnorm 0, what will it return? It's as if I'm looking up the number 0 in the z table. It'll return 0.5. Okay? So if I type in pnorm 0, it'll return 0.5. And so if I put in pnorm 0.01, it will return, if you look in the normal table, it says 0.5040 in your standard normal table that you have here. And if I enter that, we see that it has more decimals of precision, and it gives back 0.5039894. Okay, so your normal table rounds off to 4 decimals for space-saving reasons. And this goes out to many more decimals of precision. And you can also get things in between. So if you didn't want 0 or 0.01, but you want a 0.005, you could do that, okay? You know, it gives you, you can put in very highly precise decimals, and it'll give you very precise responses as well, okay? There's also a little, you also don't have to put in z-scores. You can say, okay, well, I want to know what percentage of people have scores over 120, under 122 if the mean is equal to 100 and the standard deviation is equal to 15. Okay, and it will return that to you. Okay, and essentially it's calculating the z-score for you and looking that up in its built-in z-table or normal table. Okay, and you have to enter things in a certain way, and if anytime you're not sure, you can always put the question mark, which says give me help, on the function p-norm, okay? And the help will appear over here, and for things like p-norm, it returns, there's actually four related functions: d-norm, p-norm, q-norm, and r-norm, and the ones we use will be p-norm and q-norm. And basically it says plug in your q, and then if you don't give anything, it assumes a mean of 0 and a standard deviation of 1, which is why our numbers without anything else was from the z-table. And it also has the order there, so if you put things in this order, p-norm 122, 100, 15, it will give back the same answer because it's expecting things in this order. But if you switched up the order and you did 15, 100, this would give you the wrong answer. Okay, this is not the right answer. But you could change it up, and you can do SD is equal to 15 and mean is equal to 100, and then it will say, okay, I know what you're talking about. So basically, if you follow the order that's in the help file or the manual, you don't have to say mean is this and standard deviation is this. But if you don't put it in that order, it's going to expect things that way, and you have to clearly label them as such. Okay, so p-norm will give you back the z values in the z-table, and if I said what percentage of what percentage of people have scores under 122 if the mean is 100, the standard deviation is 15? If I asked what percentage of people have scores over that, you would tell, what would I do here? I would just do 1 minus p-norm 122, okay? Because there's no function to say give me what's above. You just do 1 minus what's below. q-norm is the related function, but it will return the z-score or the score that's associated with a certain percentage. Okay, so q-norm 0.5 would give me what? 0, right? q-norm will give me 0, saying the area, if the area is 0.5, the z-score associated with that is 0. Okay, q-norm 0 would be what? Negative infinity. Okay. And you can do the same thing, you know, q-norm 0.9288 if the mean is 100 and the standard deviation is 15. What is that? Okay, 122.03 something. Okay, stuff like that. So that's p-norm and q-norm. For the binomial function, we have d-binom. D-binom is used for I flipped a coin 10 times, and what's the probability that it lands exactly 5? Okay, so d-binom, so if I say d-binom, I want to know what's the probability it's going to land heads 5 times if I flip the coin 10 times, and the probability that it lands heads is 0.5. Okay, and again, you can look at this X size probability. It's expecting things in this order. And you can also see RStudio gives you kind of the little tooltip that pops up that shows you what's the order that it's expecting. And you can say, okay, well, if you flip the coin 10 times, the probability that it lands heads exactly 5 times is 0.246. Okay. P-binom answers the question, what's the probability it lands heads 5 or fewer times? So that includes 0, 1, 2, 3, 4, and 5. Okay? So if I did D-binom 0 through 5, and I can do 0 colon 5, it's going to spit back 6 answers. This is the probability that the coin lands heads 0 times, 1 time, 2 times, 3 times, 4 times, and 5 times. Essentially, P-binom does D-binom from 0 to whatever number you enter, and then it adds them all together. So essentially, if I took all 6 of these numbers and I added them together, which I can do using R, using this function sum, I could say sum everything inside everything. And so you have to remember that this command, D-binom, which is inside the function sum, represents these 6 numbers here, okay? Oh, and it got hung up for a second. But, and it says, so we see that the answer to this is exactly the same as P-binom here. So P-binom is essentially a little shortcut for D-binom 0 through 5, okay? But using P-binom, we can answer those more complicated questions. If I flip the coin 100 times, what's the probability of getting 60 or more heads? Remember that? What's the probability of getting 60 or more heads? How would I answer that using P-binom? So remember, P-binom gives you 0 through whatever number you enter. And I want 60 or more.
1 minus P-binom?
Yeah, so I would do 1 minus P-binom, and what would I enter? I'm flipping it 100 times. Probability of getting coin is 0.5, but I want 60 or more. Very close. I would use 59. 59, 100, 0.5, because P-binom does all the calculations 0 through 59, and so if I take those away, what I'm left with would be 60 through 100, and we would get this answer. Okay. I could do it the quote manual way by doing D-binom 60 through 100, and it would give me a whole bunch of numbers, and I could say, well, sum all of those together, and we would get the exact same answer. Okay, I know it feels a little complicated and hard, and if this is your first time dealing with any kind of programming language, a lot of it's going to feel frustrating and you're going to hate it, okay? And that's just the nature of learning programming. Computers are very sensitive about typing things in exactly the way they appear, and if you have anything wrong or you're using capital or whatever, it's going to say nope. It's going to give you errors, okay? So before you guys pack up, I know it's 10 o'clock. There's the third part of the lab is going to be probably the most challenging part, and that is I want you guys to access some data from the World Health Organization, and it's just some boring data on blood pressure at different countries, okay? And so this is like the World Health Organization has all this thing, and it says if you're in Afghanistan, the average blood pressure for males 18 years and older is, I don't know, 126.1 or something like that, okay? This is systolic blood pressure, okay? So anyway, I want you guys to go get that data, okay? And you're gonna load it in here, okay? And you can get the data directly with this link right here, and it will download a little CSV file. You're going to have to load that into R. And there's a few ways to do this. One, so write these functions down. And I also have a little video that helps you, but you can do, one way is you can create a URL object using, but be sure to put your, I messed this up. So I'm going to just create something called the location URL object, and inside quotes I'm going to put that, and then I can do read.csv, this location, and we're going to store this, whatever the results of this, into just our just a thing called BP for blood pressure. And it's downloading and reading the data, and oh, it didn't like that. Okay, well, something didn't work. But the functions, you can just download the file. The functions you're going to use probably are going to be read.csv, so write that down. And then you're going to have to use functions like calculating the mean, creating histograms, and box plots. I leave this a little bit unguided to encourage you to do some exploration yourself. I'll put maybe add a few notes. You're going to run into this problem where some of the data in the data file is missing. Okay, it doesn't have data for certain countries, and so when you ask it to calculate the mean of the data that you have, if you don't do a certain thing, it's going to say, I don't know the mean. Because if I said I have 5 kids and I give you the ages of 4 of them, but I say give me the average of all 5 kids, you can't do it, right? So I can just say, well, so you have to tell R, well, I know I said I have 5 kids and I only gave you the ages of 4. Just calculate the ages, mean of the ages that I provided to you. Okay, and there's a little command, and I'll update the web page with that. Okay. Again, parts of it are going to be frustrating. Don't spend, I would say, don't spend more than 2.5 hours on this. Okay. If it gets beyond that, just stop with what you have and just turn in what you've got. It's okay. Don't hesitate to send me emails either if you got questions. So good luck. We'll see you guys next week.